through Chemilight. Today we are going to be looking into alkenes. Okay, so in our former class we talked about alkenes. Today we are going to be talking about alkenes, also known as what? Olefins. Alright? Olefins. Okay, that's an important point to note. Okay, alkenes and alkenes are alike, but they have slight differences. So now I'm going to give you the points which are very necessary for you to know about these alkenes first before we go into the nomenclature and the chemical reactions and all that. So now let's move into the points first. So now the first point you have to note about the alkenes is that they are unsaturated hydrocarbon. As we said before, alkenes are saturated. These guys are unsaturated. Alright? So now that's the first point you have to note. Unsaturated hydrocarbons. Now, the second point we have to note is that these alkenes has what? Double bond. Like now, in the alkenes, alkenes has single bond, which is a sigma bond. But these guys, they have double bond. Now, this double bond does not comprises of two sigma bond. It comprises of what? Sigma bond and pi bond. Okay? So now let's write it what? Double bond. Carbon to carbon what? Double bond. Now this double bond, now we know that it has a sigma and what? Pi bond. Okay? So now, next up, what is the next thing we have to note about these alkenes? It's very simple. Now, as we normally we know alkenes has what? sp3. These guys, because of their double bond, as we said, that's why I like arranging it like this. Double, after you know they're unsaturated, the next thing you note is that they have double bond. And double bond means what? They undergo what? sp2 hybridization. Okay? So that what? That what? sp2 hybridized. Okay? Now, what else should we note about these alkenes is their general formula. Alright? So now, their general formula, it kind of look like the alkenes, but there is a slight difference in their chemical, their general formula, right? So now the general formula goes like this. We have Cn, H what? H2n. Now, this actually, now in the alkenes, we will normally say +2, but here there's no +2. Alright? There's no +2, it's just CnH2n. That's the formula. Alright? Now, the next thing we have to note about these alkenes is that they have a bond angle. Okay, about this bond angle, most times, like compounds which possess like sp2 hybridization, they normally have what? 120-degree bond angle. Okay? So now it depends on the structure of this compound. If the compound has the sp2 hybridization, it's likely to have a 120-degree bond angle. Alright? So now the next thing we have to note is that finally the most important is what? The first member of the alkenes. Now we know that alkenes have their first member to be methane, but these guys are different a little bit because of this double bond. It affected the structure of the first member. Now normally we can say we can denote our first member to be 1, but it won't work because following the formula, if we add 1, if we say n is equals to 1, we will now have what? C1 1 times this 2 will give us what? H2. Now, if we try to draw the structure, how will it look like? It will look like this. Sure, you now get the idea. First of all, carbon must be tetrahedrally linked to each other. It has failed in the first room because it's not tetrahedrally linked to each other. And we still know that alkenes has what? Double bond. And imagine, try to imagine putting double bond here. It's not carbon to carbon linked. So we have filled again to get the second characteristics of alkene. So there's nothing like methane. It does not exist. So, but if we like use 2, like if we denote n to be 2, we will now have a formula of what? C2 H what? 2 times 2 will give us 4. This is the formula. So if we try to draw this structure now, if we put our first carbon here, 1, we will now put our double bond, link it to the second carbon. Now we balance our hydrogen. We balance our hydrogen like this. Okay? Do you get your point? It's actually easy. It's logical. Now we see that these carbons are tetrahedrally linked because we get one bond here, 2 bond, 3 bond, and the 4th bond. Now the other carbon 1, 2, 3, and 4. So they are tetrahedrally linked. Now, secondly, they still follow the same formula. So now this is why ethane is the first member of the alkene family. So now let's write it. Ethane is known as the first member or the simplest member of the alkene family. Alright? So now let's look into naming of alkenes. Alright guys, now looking at the nomenclature of alkenes, there are things we have to note. Alright? Now in alkenes, we recognize the substituent first, but this guy is different. We don't recognize the substituent first. We first what? Look at the double bond, the position of the double bond, because what? The double bond is our functional group here. Alright? So now there's a point I want you to note. As I said, we recognize what? We recognize the double bond. We recognize the double bond first before any other thing. Okay, now looking at this, what do we now do? In naming, we have to look for the longest carbon chain. Now, since we've recognized the double bond, we now know we have to count from this direction. Okay? So now counting from this direction, we have to be 1, 2, 3, and 4. We now know what is what? Both. The carbon is both. Okay? Knowing that it's both, what next? We have to look at the position of the substituent. We have an halogen here, which is chlorine, which is the only substituent available. So now what do we do? To name this compound is very, very simple. We say we first write from the position of the substituent, write 4 chloro what? Both. Since it's 4 carbon, we put it both what? Both in. Now the position of the double bond, you have to recognize it. 1, we meet the double bond. So both what? Both 1 in. Why do we say in? Because it's an alkene double bond. Okay? Now, this compound can also be called what? Can also be called 4 what? 4 chloro 1 both in. The compound can also be called like this. Alright? Okay guys, this is very essential for you to note about the alkenes. Now, the alkenes and alkenes has a relationship, but how are they connected? This is how they are connected. The cyclic or cycloalkenes are functional group isomers to what? Alkenes. Alright? So now, but let me explain what I'm trying to say. I'm trying to say that they have what? The same molecular formula, but what? Different structure. Okay? So now, based on that, we have to take example. Let's see. Let's use what? Let's use propane. So if we use propane, we can say something like this. This is what? This is propane. Okay, if we balance the hydrogens, we can balance the hydrogen as this. Okay. Here, alright. Are we good? Okay. Now the hydrogens are balanced. Alright? Now, what else do we do? As I said earlier, the cycloalkenes are isomers. So now let's cross check if it's actually correct. Now, the cycloalkenes that is correspondent to what? This propane is what? Cyclopropane. So now let's draw cyclopropane. We'll have it to be 3 carbons, right? So it can only form cycle as how? A triangle. Alright? So this is how it will be. It will now have 2 hydrogen, and what? 2 hydrogen here. Okay, now from the look of things, what do? Let's count our hydrogen first. we already know it's 3 carbon. So the formula will be what? C3H what? 1, 2, 3, 4, 5, 6. H6. Now, writing here we have what? C3 what? H6. Count it, you see. 2, 2, 2, 2 is what? 6. Now, I've now proven the point that states that alkenes and cycloalkenes are what? Functional group isomers. Now, let's take another example very quick. Let's use butane. Okay? This is butane. 1, 2. Okay, this is butane. But now, which butane is this? We have this to be but2 in, right? We have this to be but2 in. So let's just balance the hydrogen as quick and fast as possible. Okay. Okay, we'll balance the hydrogen. Now, let's draw a cyclo what? Butane. Because as we said, they have to be corresponding for it to be a isomer, a functional group isomer. So now, let's go. It will now form a cyclobutane will form what? It will form a square. 4 carbon. We've completed 4 carbon. Now, balancing the hydrogen. It already has 2 bonds bonded to 1 hydrogen. So we just have to add extra 2 to make it tetrahedrally linked, which is hydrogen. 1 hydrogen, 1 hydrogen here. I just put it together, okay? So don't get confused. Okay? Alright, so now the hydrogens are balanced here. So now let's count, let's cross check if actually what we have done here is correct. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hydrogen. So now let's write the formula. We have the carbon to be what? 4 carbon. Then the hydrogen to be what? 8 as counted. So let's cross check if the cyclobutane has the same molecular formula as the butane. Okay? So we have 4 carbon. Now how many hydrogen? 2 plus 2, 4, plus another 4 again, 8, H2. So now proving to you that this point is very correct and accurate. Okay, so please note this. Don't ever forget it. Alright? So now let's look deeper into the alkenes. Alright guys, now let's just move fastly into what? Preparations of alkenes. Okay, looking at the preparation of alkenes, what do we consider as the first preparation of alkenes? It is what? The what? Hydrogenation of what? Hydrogenation of what? Alkynes. Okay guys. Alright. Now, looking at this, it's very, very easy to understand. First of all, let's write the formula for alkynes. We have the formula for alkynes to be what? CnH2n minus 2. You remember, the first one alkanes are CnH2n plus 2. Alkenes, we are talking about CnH2n. Now, alkynes, which are triple bond, are now what? CnH2n minus 2. So now, they said hydrogenation. Hydrogenation, as I explained in our former class, is what? Hydrogenation is the addition of what? Hydrogen what? Molecule. I didn't say atom. Atom is one hydrogen. But adding 2 hydrogen is what? Hydrogen molecule. It's written like this. So now, the general formula of this equation will now be CnH2n minus 2 plus hydrogen what? Molecule. To give us what? To give us a don't forget, it must be what? Corresponding alkene. Okay? So now, the formula for alkene, CnH2n, that's all. Okay? Alright, so now this is the general formula. So if you impute any alkyne here, it will give you a corresponding what? Alkenes. Alright? So get the point. Now let's take one example. We have the first member of alkenes to be what? Ethene. Alright? So let's use ethene. How do we get ethene? We have to what? Hydrogenate what they call it? Ethyne. Okay? If you are getting ethene, we hydrogenate ethyne. Okay? So now the formula for ethyne is what? First of all, we put our 2 carbon. We know it's 2 carbon. Remember, it's what? It's an alkyne. It's what? It possesses 3 double bond. Okay? Sorry, it possesses triple bond. So we put our triple bond here. Now what else? We have to balance our hydrogen. Now, from the look of things, each carbon is missing 1 bond. So we just have to add H here. and H here. Now we've gotten what? We've gotten our ethane. And they said if we hydrogenate ethane, it will give us a corresponding what? A corresponding alkene. Okay? Alright, this is our hydrogen molecule. Don't forget, hydrogenation is the addition of what? Hydrogen molecule. Okay? Don't forget it. So now, it will give us what? Our C2H2. Okay now. Sorry, C2H4. But I want to write it in a structural form so that we'll make sure we're getting the whole gist here. Okay, let's write it in a structural form. We have to put our double bond as usual, then balance our hydrogen. So what I wrote before, C2H4 is also this, 4 hydrogen and 2 carbon. So this is called what? Ethene. So it's as easy as this. This is the first preparation of what? Alkenes. So now let's move on to the second preparation of alkenes. Alright? Alright guys, diving into the second preparation of alkenes is very simple. This one is also simple, like the first one. Is what? The process now is called what? Dehydration of alkanols. Okay, in the dehydration of alkanols, we can also call it dehydration of alcohols. It's the same thing. Alcohols, alkanols, we're still talking about the same thing. Okay, now, first of all, before we move into what we are trying to say, we have to what? Write out the formula and all that. Okay, when we're talking about dehydration, how do we dehydrate a compound? We use a mineral acid when we are dehydrating a compound. Note it. Now, dehydration means what? A removal of water molecule. Note it. Dehydration means the removal of water molecule. Okay? Now, what do we mean by dehydration of alkanols? We mean the removal of a water molecule. It's as simple as that. The removal of what? A water molecule from what? The alkanols. Now, before we move into this thing, we have to what? Draw the structure of what? The alkanols, the general structure. And we have to represent this thing in a formula so that we can be able to impute any compound and give us the corresponding what? Alkenes. Alright? So now, let's dive into it. Now, how do we draw the structure of alkanols? We draw it like this. First of all, we write our functional group. Then we put our bond. Okay, now, what this dash means, all this dash I'm putting, it means that the compound can be completed. Okay, if I balance it now, what I mean is that it's only what ethanol, but no, it can be butanol, propanol, pentanol, going higher. Okay, so that's why I didn't like balance it up. This means it can be continued. Okay, don't get confused. Now, we said the dehydration. Remember, dehydration is removal of what? Water molecule. And how do we remove a water molecule? By what? Using mineral acid as a what? As the catalyst in the process. So these alkanols, they will pass through the mineral acid. So now, alkanols in the presence of what? A mineral acid, we do what? It will what? Lose a water molecule. Now, this equation can be written like this. You can write it like you lose a water molecule to give us what? A corresponding alkene. Okay? You get it? This is how the general formula looks like. But we can also say, we can also not write it like this. We can write it like this to displace a what? A water molecule. It's the same thing. Okay? So now, looking at this, what do? We have to do what? We have to use one example to make sure we got, we get the whole point. We get. Okay, guys. Now we are going to use an example. And which example should we use? Let's use butanol. Yeah, butanol will be good. Now let's use butanol. How do we write butanol? We draw it like this. balance the hydrogen. Okay guys, now after balancing the hydrogen, what next? Remember, I said we are going to use butanol. This organic compound you see now can be called what? Butan 1-or. Or you can also call it butanol. It's the same thing. Alright? Butanol, butan 1-or is butanol. Okay? So now we said when an alcohol passes through what? A mineral acid. Now it passes what? Through a mineral acid. And what do we mean by mineral acid? HCl, H2SO4, sulfuric acid. So write it. Way to so that you don't miss it. Now, using sulfuric acid, we have to use what? A compound, concentrated H2SO4. We give us what? We give us a corresponding alkanol. That is, if we use butanol, it will give us a corresponding butane. Alright? So now, how do we now draw the butane? We will draw a butane like this. 1, 2, 3. Because it's butanol or but 1-or, we have to put it but-1-N in. Okay? So the double bond will be here. Alright? Now we have to balance our hydrogen. Okay guys, we balance the hydrogen. Alright. Okay. And that's it. We balance the hydrogen. Now we've gotten our what? We'll name this compound as what? But-1-N or butane. Okay, it can also be called butane. It's the same thing, alright? But since I did, like I told you before, it's the same thing. You can actually write your hydrogen here as it's like it's placed, or you can put it under to signify that there was a removal of what? Hydrogen molecule. There's no space there, that's why I write it there. Okay guys, now this is another process in which what we can produce alkenes. Okay, now let's look at the final process or preparation of alkenes. Then aside that, because this video is actually going to be split, this one is going to be talking about the basic preparation, the one is necessary for you to know. But the one I'm going to like the advanced alkenes video I'm going to make, we are going to add a more complex preparation than this. Alright, but this is the most important for you to know first before knowing those ones. Now finally, the last preparation of alkenes we are going to look into in this video is what? The composition of what? Esters. Okay, now the composition of esters. So now what do? We have to now write the equation. If we decompose esters, it will give us alkenes. But now, how do we get these esters? Now, if we combine an alkanol with what? With a mineral acid. Now, let me write it. Let's use, which example should we use? We use ethanol, okay? Let's use ethanol. Ethanol is written as C2H5 and the functional group, okay? These are ethanol is written. If ethanol combined with what? A mineral acid, H2SO4. Alright? If we combine it with a mineral acid, what will it give to us? Now, it will now give us water and something a little bit complex, which we are going to call ester. Now, we are going to write it like this to give us C2H5 H2, sorry, it's not H2, HSO4, displacing water. Okay, so now this is the ester which we are going to get. Now, what is this ester called? As we know this to be what? Ethanol. We know this to be ethanol. We know this to be our mineral acid. What do we call this? We call it what? Ethyl hydrogen sulfate. Okay, ethyl hydrogen tetra ozo sulfate 6. Okay, just write it, ethyl hydrogen tetraozo sulfate 6. This thing we are looking at is an ester. So now, as we said, in this final preparation is the what? Decomposition of what? Esters. Now, in the decomposition of esters, what we do? If this guy, we remove this guy from this reaction and apply heat. Note, in the decomposition, there must be an application of what? Heat. Okay, now looking at this, as I said, we will have to what? We have to like decompose this ester we've gotten here. Alright? So now, oh wow, Jesus. Now, note, it's very important. This ethanol here is what? In aqueous state. Note, this guy is in aqueous state. Also, our ethyl hydrogen tetraozo sulfate 6 is in what? Aqueous state. Alright, please note that, don't forget that guy is in liquid. Okay, alright. Now moving forward, what do? We do what here? We decompose this compound. So C2H5, sorry, okay, our ethyl hydrogen tetraozo sulfate 6. When we apply heat, don't forget, there must be a presence of what? Heat to decompose it. Now, if we decompose this guy, what are we going to get? We are going to get a corresponding alkene. And what is our corresponding alkene here? We are going to get what? We are going to get this guy, ethene. So our ethene will be written as what? C2H4. Now, after getting C2H4, what will we get? We will now have a displacement of what? H2SO4. Don't forget. Remember, as I said, this guy is in aqueous state before the heating. Now it will give us what? Ethene and sulfuric acid. Alright, so on that basis, we have now gotten all the preparation, the basic preparation of alkenes. Now we are going to look into the reactions of alkenes. But don't forget, further more advanced preparation of alkenes will be looked into in the advanced video I'm going to drop. Alright? So take note of that.
You dey use your function to play. You dey use your generation to play. What type of play is this? Look at my face. Lord of Jesus.